Hey folks, Mrs. White here. This is the last official flipped lesson video review, whatever, for the year. Isn't that so freaking exciting? It's super duper exciting. Today we are going to cover our Chapter 6 review topics. I have some good news for you around that test that I will share. And then when you are ready to take that test, you are going to let me know. You are going to hand in the Chapter 6 test right onto Google Classroom. I'm calling it a test. I do want it proctored. However, you can see, and I'm sure some of you have already looked, that right here, I am going to allow it to be open note, open calculator, unlimited scrap. Okay, now open note does not mean open book. It does not mean open friend, and it does not mean you print out all the keys to the review and you print out the keys to all the homework. Okay, you are going to organize your notes, put them together. You are going to grab a calculator and make sure you have some scrap. And I'm going to be really clear with your parents on this. I'm going to say, hey, they're welcome to have any handwritten notes that they've taken. Okay, and that's how I'm going to word it. I'm going to very specifically say they should not have access to their ebook, they should not be chatting with peers, and there should be no keys that are printed that I've made available to them online. So please don't take advantage of this. I'm doing this because I want your last week to be a little less stress, okay? And I really want you digging in and making sure you understand how to do these exponential and logarithmic functions. With that being said, we've covered 9 chapters pretty much. There are a couple things we didn't cover. We didn't cover section 6.3, which was geometric sequences, and we didn't cover 6.5, which was a modeling chapter, so it was all word problems. In fact, good news, I told you there would be some. There are no word problems on this exam. And I also took out section 6.1, which was graphing exponential functions. So although you spent some time learning and practicing that, I'm not going to put it on your test, okay? Your test is 10 questions. 10 questions only. So you can see there's 1, 2, 3, 4, 5, 6 sections. That means you're going to have 1 or 2 questions from each section. So review a little bit of everything. If you've already looked online, I've put the review sheet that you're welcome to give a go to. That's exactly what I have screenshots of in this presentation. So I did put the review sheet up. I also put a key up with the problems solved, so you can access that as you see fit. If you just want to pause the video and work on that and hit up the video as you need to, that's fine. I don't care. But again, you're only going to have 10 questions. It is going to be open note, open calculator, open scrap, no to these 3 items though. Okay, so this is going to be the pieces that we review today. I'm only going to do 1 problem from each section. So section 6-2 had us solving exponential equations, and these were exponential equations where we could simplify the bases really easily. Okay, so maybe let's take a quick look at, let's do 19. So in 19, I see that I have a base here and a base here. Neither of them are prime. So we could take that 8 and rewrite it as 2 to the 3rd power raised to the 3 minus 3y. Over here, I have 256. Now, 256, I notice, is even. I want these two things to have the same base, so I'm assuming this is a perfect divisible by 2 over and over and over again. So I'm going to take my 256 over here. I'm going to divide it by 2. 256 divided by 2 is 125 plus 3, so 128. 128 is even, so it's going to be, I can divide it by 2, it's going to be 64. Ooh, 64 I know does divide by 2 again, that's going to be 32. 2 again, that's going to be 16. 2 again, that's going to be 8, and I know 8 has 3 2's in it. So 256 is the same thing as 2 to the 1, 2, 3, 4, 5, 6, 7, 8, 8th power. So I could rewrite this 256 as 2 to the 8th raised to the 4y. Now the reason that I do this, folks, is because if they have like bases, the bases can cancel, and I can use my power to power rule to simplify this. So in order for these two things to be equivalent, the bases have to be the same and the exponents have to be the same. Since the bases are already the same, that means this exponent would have to equal this exponent, and that's what I'm going to write right now. So 3 times 3 is 9, 3 times negative 3y is negative 9y, 8 times 4 is 32y. So exponent must equal exponent if the bases are already the same, and that's why we do that. Next, I'm going to get all my y's to one side. I'm going to add 9, and I get 9 equals, if I add 9y here, I get 41y. I'm going to divide by 41. 9 is only divisible by 3, so I can check really quick on my calculator if 41 is divisible by 3. So 41 divided by 3. It is not a nice number, so I'm not going to simplify it. That is my answer, 9/41. Okay, and that's how we go about those. We want them to be the same base, so we kind of do the prime factorization of it. In section 6.4, so we're going to go quick. Okay, this is meant to be a quick video, so you can practice what you need to, and then let me know when you're ready to work on your test, okay? So, actually, not let me know, let your parent know that they need to let me know. So next we had the introduction to logs. I am not going to have you graph logs, but you are potentially going to have to rewrite logarithms into exponential functions and or evaluate logs that don't have a common log. And there's a couple ways that you could do this. Now we have a couple strategies, but I'm going to review what we learned in section 6.4. So to rewrite things into exponential form, I take my base, I put it to this power, and I set it equal to this. So I'm going to have 2 to the negative 4 equals 1/16. Okay, and if I look, that is right? 2 to the negative power means I'd put the 2 underneath, and then 2 to the 4th is going to equal 16, so 1/16, that works. Okay, I do something similar when I write it in logarithmic form. I guess I'm going to do almost this whole section. Whatever's holding up your exponent is your base of your log. So I'm going to have log base 10, which if you put log, right, any log base 10 is the same as common log. So log base 10 of 100 equals 2. And so we always kind of do that circle. Log base 10 of 100 equals 2. And that's what works. And you can go back and check the opposite way, right? 10 to the second power equals 100. Okay, it does work. Lastly, let's take a look at these. We'll just do 43. So when you were asked to evaluate back when, you did not use common logs. This was before we learned about the common log. So we said set it equal to x and then rewrite it in exponential form. So we'd have 4 to the what power equals 256. So then we'd go on our calculator and we'd say, okay, 4 times 4, well, that's 16. 16 times 4, well, that's 64. 64 times 4, oh my gosh, it's 256. That means 4 to the 4th equals 256. That means x must equal this exponent, x must equal 4. Okay? So that's how we tackled it in section 6.4. Hopefully right now you're like, Mrs. White, can't we just do common log of 256 over the log of 4 and find what that is? And the answer is yes, it will equal 4 and that will work, right? Because that's how we also can solve for weird bases. Okay, but if you try to solve for this and it doesn't turn out nicely like this one, then you would have to use common log. Just so you know, if you're like, well, when would I do this and when would I do that? You could do common log all the time, or you could rewrite it, and if it doesn't work out nicely, like you don't have a nice exponent that you find, then use common logs as a backup. Next we had log properties, and there are technically 3 log properties. So you have your addition property, right? Which means that if you have a log and you're adding the same log to it, you actually multiply your 2 of pieces. Okay, and that simplifies it. You have the subtraction when you have some log minus some other log and they have the same bases. It's division. Okay, you divide your 2 of pieces. Your top number is your first of and the bottom number is your second of. The last one that we have is the power rule. And that lets you know that if you have some sort of exponent, okay, up here, you can bring it out front and write it as a coefficient, and vice versa. If you have a number here, you can rewrite it as an exponent on your of piece, okay, and that's our power property. So these are our 3 log properties that you would use to simplify and then solve. So these are all, I want to be very clear with you, these are all on your review sheet. The gnarliest of all of them looks like 60. So why don't we do 60 together? If you feel good about this, then just listen to this one and then you don't have to do practice. It's up to you, right? You pick and choose what you need. So I notice I have a log plus another log. When I see addition, I'm automatically thinking multiply, okay? And these logs have the same basis, so I can. So I can rewrite this as 1 log if I multiply my 2 of pieces. So this is the same thing as log base 6 of 8 times n, which is 8n, and 8 times negative 4, which is negative 32. Then over here, I notice I have the same log bases, but they're being subtracted. When I subtract, I need to make it a division problem. So I'm going to have log base 6 of top divided by bottom, and it's always got to be in that order. So n plus 11 over 2. Now, since this side is as simplified as it can be and this side is as simplified as it can be, you have to make a choice. If you have a log equals the same log, you can cancel out each of those logs and keep going. If you had a log equals a constant, right? So let's say there was like the number 3 over here. I would need to rewrite my problem in exponential form and then go from there. Okay, so I want to be really clear with you. When you have log equals log, they just cancel. But if you have log equals number, change the form. Okay, change the form into exponential and then keep going. So I get to cancel those out. So I'm left with 8n minus 32 equals n plus 11 over 2. And you might be like, I don't know what to do right now, Miss White. Well, we want to move all our n's to the same side, but we can't move this n over here until we take care of this 2. So I'd start by timesing by 2 here to cancel that, and then timesing by 2 to both of these over here. So I end up with 16n minus 64 equals n plus 11. Because remember, when I divide by 2 and times by 2, it cancels. So now I'm going to minus 1n minus 1n and get 15n. I'm going to add 64, and I'm going to get 75. If I divide both of them by 15, I get that n equals now, I don't know if this simplifies perfectly. I'm going to try to do it without a calculator. So I know 5 goes into 15 3 times. I know 5 goes into 75. Oh my goodness. 5 goes into 7 once, and there's 2 left over 15 times. And 15 over 3 does simplify nicely, right? It becomes, 5. Okay, so our answer for this problem is a nice number. It is just straight up 5. We should take that 5 and we should plug it in, right? So here's my n. 5 minus 4 is positive 1. That's good. Remember, I can't have an of that's negative. If I put a 5 here, that's 16. It's not negative. Good, I'm good to go. You need to make sure you double check that your ofs, when you plug it in, are not negative or 0. Okay, you can't have a 0 there either. So that's how we go about using our log properties. That showed our addition and subtraction. It does not show our power. So really quickly, the power one would just mean that you would take that 3 there. Now you can solve that. 2 to the third is 8. This 2 would go up here. It would be squared. It's going to have to stay x squared. Okay, you need to do your powers before you do any addition subtraction. Just heads up. Hopefully you knew that already. Let's keep going. Okay, we're like lightning today. 6-7 had us looking at the common log, and then 6-8 has us looking at natural logs. So we kind of tied those both in as far as notes were concerned on the same day. So let's take a look at our common logs. So you're asked to solve each equation or inequality. We only did equations this year. We did not cover inequalities, and then round. So in these types of problems, you have a couple choices. You could, one way that we've seen these solved, and so maybe we'll just do 63 because again, it's like kind of convenient. One way that you can tackle this is you could change the form because we have a variable in the exponent and then see what you have. Okay, and in all of these you have a variable in the exponent, so that might work. Then we could potentially use our common logs to rewrite them and solve them as a decimal. Or we have a strategy where we can just apply the common log to both sides, bring our exponent down, and do some work there. Okay, let's start by rewriting this. So this is the same thing as, so log base 6 of 28 equals x squared, right? That's how we write it. Log base 6 of 28 equals x squared. So because my x is almost alone and positive here, I'm going to try to solve this chunk and then just square root each side. So I want you to take a quick look here for a second. You might say, how do I solve this, Mrs. White? You solve it with the common log. Okay, so we're going to do log of 28, and this is our base change formula, over log of 6. Remember, we do log of this over log of this, and that's going to help us get a decimal. And then what we're going to have to do is we're going to have to square root both sides. So essentially, and we put plus or minus because we're square rooting it. Essentially, we're going to find this decimal first and then square root it. So let's go to our calculator. And I'll use my computer one just because I know not everyone has access to a graphing calculator. So log base 10, remember that's your log. So I'm going to do log, oops, excuse me. I type in my of piece first. So let me clear this out. I'm going to type in 28, and then I'm going to do log base 10. Okay. And then I'm going to say I want to do that divided by the log of 6. And I get 1.8597. So I'm going to write that down. Plus or minus 1.8597. Now I need to square root that number. So I'm going to pull back up my calculator. And I'm going to literally just come over here to my square root button and click it. And I get 1.3637. And there's my answer. Okay, so I could have two x values, the positive version or the negative. You can have positive or negatives here. Because that exponent's going to be squared, it's going to end up being positive either way once you square it. Okay, and I could double check that by squaring that number, raising 6 to that power, and making sure that it equals the 28. Okay. So that's the way that I like to do it. I like to do base change formula. So I change it to its logarithmic form. I notice that my x is not any part of this since both of these are constants. I can just do base change, which is log of your of piece over log of your base. And that's going to give you the decimal equivalent. And then I had to square root here in this specific problem. Okay. In this problem, I would have to minus 1 minus 1. All right, there's a couple other things you'd have to do. If you have any questions about that, then you can feel free to hit me up during office hours. Let's just take a quick look at this. They're asking you to express each logarithm in terms of a common log. You have a problem worded very weirdly like this. They're just saying use this. Okay, so rewrite this as two common logs being divided by each other. So it's going to be log of your of piece, 295, over log of your base. And you just solve that on your calculator and you get a decimal. And so this one is going to be 3.17. I'm just going to look at my key real quick. 3.1740. Okay, so you would need to include both of those pieces if it tells you to rewrite it as a common log and if it asks you for the to approximate the answer. They want this. Okay. Let's take a look at the natural log. You could be asked to solve things that are in exponential form or logarithmic form. Remember, the natural log has a base of e, which is that really special irrational number. And so these two things are kind of synonymous, right? This would be our exponential form of the natural log, and this would be the logarithmic form of it. So if they're asking you to solve this problem, and I guess maybe we'll do 78 and 80. That way you can see one as the exponential and one as the logarithmic form. You're going to first get either your log piece alone or simplified, or you're going to get your exponential piece alone or simplified first. So the first thing I'm going to do here is I want to get my e to the negative x alone. I'm going to minus 1 to get 14, and then I'm going to divide 2. So I'm going to have e to the negative x equals 14 divided by 2, which is just 7. Now I have my e piece equals a constant. So you might be like, I don't know, what do I do here? Every time that you pause and you're not sure, you're going to change the form. This also is exponential equals a constant. That should clue you in every time it equals a constant that you're going to change the form. So the way that this works is this is my base, this is my of, this is the other side of my equal sign. So if I have log base e, that's the same thing as the natural log of 7 equals negative x. And the reason why this is awesome is I can calculate the natural log of 7. Okay, I'll pull back up my calculator. I'm going to do 7 natural log. It's 1.9459. Now, so let's write that here. 1.9459. If that equals negative x, to get positive x, I would have to change this sign. So there's my solution to that, okay? So get your exponential piece alone, rewrite it in its logarithmic form. Now here, if I were to draw a wall, this is as simplified as it can be. All of your normal exponent properties might or could be applied to the natural log. Okay, so if you had a natural log plus another natural log, you'd have to multiply your of pieces. Here, we end up with a natural log equals a number, and this can't be simplified, and this can't be simplified. So every time you have a log and a constant, you need to change the form. So remember, this is base e, So I'm going to do e to the 5th equals this chunk right here. 4x minus 1. Now, to get my x totally alone, I would have to add 1. So I'd have e to the 5th plus 1 equals 4x. And then my last step would be divide everything by 4, right? Now, I wrote it like this, but I actually can solve that. I can do e to the 5th, and then add 1, and then divide by 4. So I'm going to do e to the x. Okay, so let's clear this out first. So I'm going to do, let's see, that's e to the 5th, and then I'm going to add 1, press enter. Okay, make sure every time you do something you press enter. Now I'm going to divide by 4. And I end up with 37.353, and then I have to round this up to 3. So 3533. And that's my answer. Okay, that's what x equals. Hopefully that's enough to review how do we solve natural logarithms. Remember that if it's an ln, you have the base of e, it's not written there, and if you have an exponential form with an e as your base, you have to rewrite it as a natural log. So then lastly, excuse my yawn, we have solving all of it all mixed together. And I'm going to let you know that this section 6-9 is pretty much what your test is like. It's a mixture of solving all over the place everywhere. That's what you're looking at in this entire exam. Okay, and by entire exam, I mean all 10 problems. So let's take a look. I mean, these are all pretty similar to stuff we've done. Maybe let's just do 87. That way I know we've done a fractiony one. And then otherwise, hopefully you'd be okay with these. I want to remind you there are times where you have a quadratic. You've solved a lot of these, so I'm feeling not guilty about not doing a bunch. If you have a quadratic, make sure you test both pieces, right? Because 2 could work, 1 could work, or none could work. So in this problem, you have a couple options. I could say 2. We'll go over both strategies. I could rewrite it. Okay, I could say 2 to the x equals 1 over 64. And I actually like this way because I can figure out what x is using kind of logic. Okay, the other strategy I could do is I could say, oh, I have all my constants over here equals x. I could do base change form. I could do log of 1/64 over log of 2 equals x, right? Because this can be rewritten as this, okay? Both of these strategies would work. Let's go to this top one real quick because this one is logic, so I have to kind of think through it a little bit. If I'm going to have a 1 up top and a number below, that means this exponent is going to have to be a negative, okay? That would make it a fraction, and it would move my 2 below. Then I would ask myself, 2 to the what power is going to give me 64? Well, I know 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 2 is 64. So 2 to the 1, 2, 3, 4, 5, 6. But I need it to be pushed below, so it's going to have to be a -6. That's going to be the power here. And I could double check that, okay? 2 to the -6, negative means move it below. That would give me 1 over 2 to the 6th, and 2 to the 6th is equal to 64, so I know it works, okay? Here, again, I could just use my calculator. I could do 1 divided by 64, apply it to the log. In fact, we'll just do that. So you can see. So let's clear this out. I'm going to do 1 divided by 64 equals. I'm going to apply it to the common log. Then I'm going to divide it by the log of 2. So 2 and log equals, boom, -6, same exact answer. Okay, so one strategy isn't always the only way that you can tackle these. Okay, I could have kind of used logic here to think about that. I could have used my common logs to write them out in base change form. Okay, again, I knew that I could do this strategy because it was all constants here with a variable on the other side. You can't do base change form if you have an x over here. So for example, we couldn't use that strategy here because our x is part of it. Log of x over log of 4 isn't going to help us out. Okay, so yeah, just food for thought. In this one, you might want to rewrite it. Okay. So feel free to do more practice as you see fit. You can see that all the problems included in the review are in this sheet. So if there's anything that you weren't quite sure of as we kind of flipped through it, feel free to hit it up and hit up the key that I have put for you online when you are ready. So literally it could start this afternoon if you wanted to. Have a parent email me. I will send them those 10 items, organize your notes, and get ready to take it and send it in. I'm asking that you submit this test by Thursday at midnight. That way I can have Friday to do my correcting. Okay. Since I have to have grades in, I need a day to make sure that I can get all these tests corrected and put in, and heaven forbid, hunt down someone who maybe didn't send it correctly or something. Okay. So again, open handwritten note, open calculator, open scrap, no printed keys, no book, and no friends. Okay. Not that you can't have friends, but you can't use them on this test. I hope that we're ending on a strong note, folks. I miss you all. I hope you have a fantastic summer, because I probably won't be seeing you. And yeah, I hope to see you next year. Bye, folks.